discussion. I will maybe mention just a couple of, let's say, questions, and then we will go one by one, colleagues, to have first round of their interventions. And then, of course, if there is any question also from the audience, please feel free to jump in once when we hear first round of the discussion. So I would just say a couple of, let's say, maybe, I wouldn't say questions, let's say maybe keywords, like what are the core technological pillars and requirements for scalable physical AI systems? I think we heard a lot about this from various interventions, both from the data, APIs, SDKs, and so on. What are the key technical, economic, societal challenges? I think we also heard from ETSI and ITU some, let's say, and also from CAI as well, some reflections on that, which I think are very important, and I think this also needs to be taken into account. How are different international standard organizations approaching the standardization of physical AI? Where do we see, we heard also a bit about the collaboration, but I think we also need to talk about also complementarity and where this kind of converges, because there are various, let's say, aspects that needs to be standardized, and various organizations are doing, let's say, doing it at the different levels and at different layers, and how this all fits together. And then, of course, how standardization is critical for the commercialization, scaling, and interoperability. And then, of course, if you want to comment anything about the future trends and how do you see future developments, I think would be also good. I'm not asking any one of you any particular questions. I think these are a sort of the possible topics that you can tackle. And then I think we have about 40 minutes and we have 5 interventions. So I think we can start, let's say, with a 3 to 4 minute interventions, and then we will see if there is any question from the audience. So maybe we can just start from my left side on. So maybe you can take first step. Thank you.
Okay, good question. So as I said, as an industry-centric perspective, we believe that in order to scale, we need to first solve the data problems. So there are many theories on how we might create a physical AI or VLA's scaling law, but in order to see if any of that theory is correct or not, we first need to have a sufficient enough training data set to test our theories. So I don't think that task can be done on any single organization or company, or maybe countries. It needs a global ecosystem to standardize some sort of way to make a general physical AI data set. Maybe it can be navigation, it can be manipulation, it can be both, it can be some kind of tool usage, but maybe with help of the good members in our community, we can find a very good way to maybe make a data set that can scale. And secondly, Kronos Group has also made a very good comment about the current status of neural accelerators, so-called NPUs. Actually, we were the one that looking onto that domain because we need to commercialize. We need to put a brain to a robot or a vehicle. So we have looked for many options. We contacted like Qualcomm. We tried to use NVIDIA's Orin series. We tried a lot of chips, maybe some Korean ones from Rebellion and the kind of NPU makers. But from all of the experiences, I clearly saw that there is no standards in utilizing that NPU's performance, because we want to use it, but in order to use any of them, we need to use like 6 months of our software team to make some kind of inference engine on top of existing SDKs, existing hardware architecture, which is a very costly and ineffective task, which lead to, at the end of the day, we just have to blindly pick a single chip and say, hey, this is our destiny, and let's use this chip to commercialize. Because we cannot test every chip in the market. So I don't think this is a very healthy ecosystem, because the consumers cannot like validate and pick a sufficient chip, because every chip maker says our chip is like 150 TOPS, so we have very low electricity consumption, watt per like tokens, whatever. But in reality, it's all different. When put into real world use cases like high temperature, high vibration, like industrial settings, the performance are all different from chip by chip. So I don't know about the hardware itself because I'm not a hardware master. I'm just a software engineer background. But I clearly see that there are many problems in commercialization because in order for the companies to put massive funds into physical AI market, they first need to see if it can actually earn a revenue or profit. But for profit, we need edge device, which is very cost effective and massively scaling. So I think there are a lot of things to be solved in this community, but this is my take on the current status of commercialization. Yeah, thank you.
Thank you very much. Kai, you can continue. Not necessarily on the same topic, but
thank you. I think, as I mentioned before, the physical AI or embodied AI is on its very early stage in terms of its industrialization. I think, most challenging things is lies on data. In terms of in the life cycle, there is a life cycle for the development of EAI system. For the model training phases, we are facing very challenging things, including how to collect the high value data. I can share some of the exercise in China. There are 60 data collection farms currently in production already in China. Each of them has a very large scale, at least 100 workstation for the teleoperators to collect data using different bodies to for the dedicated tasks. It is money consuming and human labor consuming tasks. For example, one operator only can generate 200 items of operation one day. But to training and generalize the model, it needs maybe one task, maybe 10,000 or more than 10,000 data points, even for a grasp a bottle. That means this is a task to very stable succeed of this kind of tasks need to many a very large amount of training data in terms of in the training phases of the model. But the challenge is that there is a very debate on the model architecture right now. Some people say the VLA is a destination, and some other companies not agree with VLA is the only way to forward. They use VLM and other segment hierarchical models to integrate together to solve different sectors. So not just a challenge of data, but also how to utilize scaling of the data in the future. I think it is an open question. Not we have no clear idea on what's the right. Yeah, it depends on the exploration of the ventures, and this is on the development side of the challenge, and the other side is how to apply this kind of machines into real scenarios. There is a need for the secondary developers based on the machine, the robotics in several. So the secondary development community is very important. It is in the middle between the advanced robotics company and the very broad vertical customers. So I think this industry segment sector is not. It's a gap. It's a very big gap in not only in China but also in other countries. So how to fertilize such kind of developer community is very challenging because the underneath the underlayer technology is evolving very fast. And who will win? Which one of the suppliers will win? It depends. So it is very hard for that kind of layers emerge. So there is a gap. There is no data in the real world can circulate back to the frontier technology for training. So I think it is very challenging. So in that case, standardization could bridge this kind of gap in terms of data standardization, how to evaluate the foundation model, and how to set some directions for the model involvement. Because no assessment, no improvement. So the model itself, and also we need to think about how to standardize secondary development interfaces for to decouple the application layer and the body layer. Like we have Android system ecosystem, we have Windows ecosystem to better. Yeah, to foster the diversity. Yeah, okay, that's my thought.
Thank you very much. So I see some, let's say, patterns developing from the interventions like data, NPUs. So we also see some links between the interventions and then this gap, let's say, between the developers of the, let's say, physical AI and the users, which means that we need some sort of the, I wouldn't say intermediaries, but let's say developers in between helping there. And then again, data training of the large models, and then let's say feedback loop between the users and developers. Scott, I think you can take it over. I guess you have, yeah. I'm
going to take a slightly different tack to this. I think that one of my concerns is that in order to develop AI, develop robotics models, there's a huge amount of investment. I mean, and you have, to your shareholders, to your board of directors, you have to protect that investment. And one of the dangers of that protection is you actually decide that you're exceptional, that you decide that standards are actually going to risk your investment because somebody else is going to share that. And that's something we have to break. That's thinking we have to break. We have to break it down at the board level. So we have to recognize that you're serving not just your shareholders, but you're actually making a market for other businesses and other organizations to work. And one of the great things about standards is they actually have the potential to massively increase your market. So if you think about it from the cellular radio world, before we had GSM, we had a whole bunch of inoperable or systems that offered you some form of mobile phone. They didn't interoperate very well. They are massively expensive. They just didn't offer any service. And what GSM did was challenge that entire world by saying, you shall use this frequency band, you shall use this modulation technique, and you shall develop a common market. And essentially what that made was everyone decided to share and pool their intellectual knowledge to make the market bigger. And suddenly you got from a market which is a few tens of thousands of mobiles to what we have today, where there are, 8 billion mobiles on the market just now. There's only 7.5 billion people on Earth, and we sell more phones than we do have people. And if you extend that into the IoT world, we now have more devices using our 3G, 4G, 5G, 6G networks than there are people and devices available in the market. That is because of standards and because we agreed to give up our exceptionalism. So one of the challenges to the long-term success of AI, of robotics, of the next generation is defeating exceptionalism, defeating the view that you in the market are the only important one. So the moment we have lots of APIs, because everyone thinks their API is special. Well, actually, shouldn't we just abstract from that and say, what are the commonalities between all your APIs? And you'll find that there's actually an amazing amount of commonality. There's 90% commonality, but in the market, there's 90% divergence. What we need to do is move away from the 90% divergence towards 90% commonality, and then start ramping that up to get 95%, 99% commonality, because that's where standards work. And if we get to the point where we get rid of this exceptionalism issue, go towards common understanding, common frameworks, then we have much bigger markets. We have less exceptionalism, but we also have less fragmentation. And the nearer we get to that kind of common market, common standards, common capability, then we have essentially what Denning said a few years ago, that just because we have standards for the size of timber, the shape of a brick, it doesn't mean all our buildings are the same. We can build exceptionally varied infrastructures from common frameworks. And I think that's what we should be looking at in AI and machine learning and in the future of robotics. Let's break exceptionalism, go towards standardization, then we will have a global market that we can actually sustain. I think the path at the moment is probably unsustainable. You certainly have this picture given by a number of economists now saying that the AI bubble is going to close because there's no market for investment to come into it. The reason we can challenge that is if we do standards, break exceptionalism, we open up the market and for investment, because there is a potential for the future to build. And I think if we go down that path, we will achieve the goals that we're talking about in this kind of community, this kind of event is all about breaking that. And if we can work together to break that, then we can work together to share our APIs, share our IPR, share our understanding, and get bigger markets for all. That's it.
Thank you very much. I think it's a very interesting thinking. And again, I'm coming back to what I mentioned before. There is a lot of standardization activities, both, I would say, in a private and a public sector. Let's put it like this. And the thing is, of course, how this will converge, because at the end of the day, I think some sort of convergence and let's say what Scott mentioned, let's put it like this, avoidance of this exceptionalism will have to come, because we saw it from the other examples, how it works. And I like your analogy when you said, like, you know, even if we have, let's say, the same approach of building, the buildings will not be the same, which is actually quite true. Let's continue with Markus. I think you also heard from other colleagues some references, let's say, to your presentation. So I think you will have a couple of points to pick up on this. So please, take the floor.
Yes. So first, thank you, Scott. It's really hard to add more to the request to standardization and what I am asking as well. Yeah, we really have to build a common market to build up an ecosystem. So me working for NVIDIA, people ask always, why does NVIDIA want to have standardization? You have CUDA. We need standardization because there is a market for CUDA. But there's also a market where CUDA is not the correct thing to do. There are applications which have to run on multiple device applications. And if we don't standardize there, we can't expand our markets as well as any other vendor in this room or working on NPUs or GPUs. We need to enable people to spend their time on writing new innovative software, new innovative machine learning algorithms, and not spend many years of engineer work just trying to integrate the NPU stacks. This doesn't make any sense, that each and every company would have to do the same work all over time. This is a waste of manual expertise which is rare in this ecosystem. Also, quite interesting would be how all those organizations could work better together. So we as Kronos, we come from the hardware perspective. So we have a lot of IHVs who want to expose exactly what the hardware does. What we are lacking is a view from the industry or the high-level standardization, like, okay, we are in need of certain operators. Can you, Kronos, please ensure that we can standardize those in hardware? So what can Kronos do on the higher level side? For a long time, there was a request to go more low level for Vulkan and graphics, which made a lot of sense. But for machine learning, because the hardware is so diverse, going this really, really low level means that you can't have a single algorithm anymore working on all kind of hardware efficient. So for machine learning, in the current point of the device hardware, we have to think about going to a higher level again. So while it's still great to be able to have low-level performance optimization, and you might need it for certain applications, at the same time, we also need the higher level so that the vendors can bring the best of their hardware, their diverse hardware, as you mentioned, so that people can utilize the hardware and not be scared to optimize or not being able to optimize. Then we will have software which doesn't run energy efficiency. And assuming you have physical AI, you have a robot, and you don't have the best possible implementation of the neural network on this robot because there's no good common API, you didn't have time and resources to optimize, then you might waste 10% of the robot battery lifetime. So you will have to charge it more often, you need more power plants and everything. We should really standardize in a way that everyone can bring the best hardware performance to this API.
Thank you. And then Seungwon, please, you can take it over. I think you also made in your presentation quite, I would say, a couple of interesting, let's say, points which I think you can pick up and complement what was said already.
I think that we thought about that the complexity of the system. Actually, my presentation is one of the new member and new component to increase the complexity, computational memory. But I think that the complexity of the system continue to increase because of we needed to reduce power and we make the various application in our system. So I think that we cannot escape from the complexity of the system. But we think about that software to operate such a kind of complex system. It could be another big vulnerability to maintain the operate well and maintain well. So I think that actually I did not have good answers for the questions, but my concern is that including me and many people add more components into the system for the AI, especially for the case of physical AI systems. But we cannot make a guide rule or a guideline how to operate reliable in terms of the system operations. So I think that for the standardization, we thought about how to operate a reliable system with the various components and various softwares, especially for the physical AI. Thank you.
Thank you very much. Do we have any question or comment from the audience? That would be interesting to hear. No? Yes. I don't know if we can give you the microphone. Yes.
Hello, this is Seungwon from SG Korea. So I'm also working in the IT sub-20 regarding the standard work on this topic. Okay, I heard some very insightful presentations from our speakers. So thanks so much about your insightful presentations. I heard that there are some important three pillars for AI. It's hardware and some data and some evaluation something. And also when this speaker mentioned about the importance of the data standardization, also the Markus may present some, explain some importance of nature of the interoperability issues in the physical AI. So I think the data set is very important, most high priority issues at this moment. But I think the physical AI may composed of different components. I think also there are many key players work on this AI, physical AI. For example, the infrastructure provider and some service application provider and the users, manufacturers all have to work together to make the ecosystem for physical AI. In that sense, I think the interoperability is the most important key issue to make some kind of ecosystem for physical AI. In that case, I'd like to ask our speakers that what kind of technical issues should be highly taken into account for providing the interoperability issues of the physical AI, also how to make the ecosystem for realize this physical AI in the future. So could you show your, explain your view about what kind of issues should be highly taken into account for providing the interoperability topics to realize physical AI system? That's my question. Thank you.
Thank you very much. Anyone who wants to take on this, give a first try. Yeah, Markus, please go ahead. If you
So I had some problems understanding everything what you said. So you are asking what next steps needs to be taken in the industry to ensure that we get this acceleration?
So what kind of technical issues for the supporting interoperability?
Oh.
And what kind of technical issues should be taken into account first to realize the physical AI standardization, interoperability, and some providing some ecosystem, make ecosystem.
So
There are different technical issues for the regarding interoperability topic, I think. So I think, I just want to hear your view about what kind of technical issue need to be highly handled by in the aspect of the standardization for supporting the interoperability and how to establish the ecosystem based on these technical issues. I mean, I'm asking you about the standardization issues.
Okay, so standardization issues. So we need to come in agreement about how an API should look like. And to come to this agreement, first we have to ensure that all the IHVs realize that there is a need to define such an API. And the request to make such an API has to come from the software developers, software vendors. They have to come to Kronos and say, we really want you to define such an API, and go to each and every IHV and tell them, please standardize. At the moment, IHVs think it's okay that they expose their own API, and as long as they get away with it, they don't want to invest. So it's the real issue is really the pressure from the industry to say, please standardize. It's probably like in the GMS case in the past. So every phone before did work, and unless someone comes and says, I want to have all phones work together, no one is going to work with the others because they want to have some special magic and they think they're better with something. But someone has to come and say, this doesn't work anymore, please standardize. And this is the request from Kronos coming here to South Korea, where a lot of NPUs vendors are. Do you see this value? And if you see this value, please join Kronos and come to the meetings so that we can start discussing your needs in standardization. We can, yeah.
But part of that problem is if you look at the members of Kronos, you look at the members that we need for to address the problem. Kronos is hardware based. It's very much hardware manufacturers centric, and it's not hardware that is going to define the interoperability issue. It's the data users. So we've actually got to open a much wider world to who's involved. And the stakeholders, like if I write or develop a piece of hardware, I develop the API that interfaces to my hardware, and I do that in collaboration with a few customers I have just now. Then when my customer base gets bigger, and they've used something else in the past, it becomes much more complicated. You have to have this commitment to interoperability essentially from the get-go, from the first day you put that you're thinking into how you're developing a piece of silicon, into how you're developing that silicon to the market. That requires a long-term rethinking about how you do things. And it takes that. So yes, you have to have the data users involved. You have to have the data processors involved, so the NVIDIAs in the world, the people that Kronos represent. But without Kronos getting input from the people who are designing the applications, the people who are designing the end user, the interface themselves, then we're always going to get this fragmentation. And so fragmentation and standardization requires us to, I say, break that whole exceptionalism issue. You have to get in buy-in from the entire ecosystem, and that's hardly straightforward. I mean, I'm not sure NVIDIA, even though they have a huge market share, really understands who's using their kit and how many different ways they're using it and how much effort they've had to make to interoperate with that kit. So a lot of the problems we're talking about here as if they're well known to everyone. But in fact, I don't think they are very well known. I don't think people come forward and say, we've just wasted 6 months or a year of effort, and that might be tens of thousands of man hours of effort to make our product work with your hardware, with your API, and I've had to do the same for somebody else's API. If that knowledge is not known, then there's no incentive to make the standard work. So ultimately, it requires people to stand up and say, I have a problem because these two APIs are different. And if they don't come and tell us about it, we'll just assume everything's perfect. And it's only at large events like this, when it's multi-vendors talking to multiple operators, multiple developers, do we actually get to the point, maybe we've done something wrong. And until we accept that, we're going to continue with fragmentation. So it's a bit of, everyone in this room's got to go around and say, why aren't you working with the same API for everyone? Why aren't you working with the same interface? And until they agree, oh, right, we've done that, we've kind of hidden away that development cost because we're passing it on to our customers. And your customers, I'm paying 10% of my product cost because you've had to do it for 2 different vendors. I want you to get rid of that. And until the investors, the boards, and everyone else is aware of the cost of not having standardization, then we'll continue fragmentation. And fragmentation is obviously the death of standards. Standards is the unification that breaks fragmentation, that makes these things open, but it also has to make it public. And until we agree that we have a problem, nobody's going to solve the problem that's not seen. So let's talk about the problems we have, get those problems up front. That means we'll begin to look for solutions. If we continue to hide them because it's a development cost we don't really want to share with our competitors, then we'll continue fragment, we'll continue to lose the basis for standardization.
Thank you, Scott. I think I also wants to make short intervention.
Yeah. Thank you, Mr. Dr. Khan's question. I think it depends. Every institution, everyone has their position on the prioritize the standardization problems they want to do. And also depends on the business model the AGI, embodied AI will going. For example, there is currently some Chinese companies eager to want to do everything from the hardware, not only the computation hardware, but also the body. They do their own by their own, and also the model itself. So it is a totally vertical integrated like Apple system. And the other ones want to decouple the developers and the hardware, and developers decouple the model and the body. It depends. We don't see any clear future. So in that case, the priority of the standardization is not very clear right now. but I think from the very beginning, when we talk about the standard at the international level, we need to take action on the very common consensus parts of the new things. For example, how to recognize this system, how to assessment, how to tax this from the outside. In this case, the regulators, the users can well know the technique, the products itself. This is the first step, and then maybe safety, security guarantees of the system, and also some interoperability between different machines, because we want to use in a collaborative way of the machine. So maybe like nowadays in MCP protocols, we may need to robotics protocols to collaborate in a single mission. So I think I listed some of the very important technical standard requirements on my slides, but it depends what's the priority you can sort. Yeah. So that's why we are here at the GISC meeting. I think it is a very good moment to sit together. We see TTA hosted this one, and ETSI leaders come here. I can represent MIT TC1 from China. So Korea, China, Europe can work together for further discussion to prioritize the international level of the standardization. And we can bring some concrete consensus into, for example, ITU for the international level of the efforts for future. Yeah, I think it is very important for people to sit together, to meet, to share information, and to find a way forward. Thank you.
Thank you very much. I think this fits also what Scott mentioned, in a sense that we need to identify, I wouldn't say problems, but let's say challenges, issues, and then work together on them as much as it's possible. We have like 4 minutes to the end. Any of the panelists wants to make any last comments? Yes,
Okay.
please.
So as we have Kronos Group here, actually I go to a lot of speeches, and every time I go to semiconductor-related speeches, I always say we need standardization in NPU. So actually, I've learned about Kronos today, right? And so I can contact you, right? So what is the best way to talk about hardware-related standardization issues right now at the moment?
Talk to us. Yeah, so yeah, you can join Kronos if you want to really participate in the discussions within the Kronos group. If you want to have a meeting, I'm a main council chair, you can contact me, we can talk about your interests. I can take all this information and lead it to the group as well if you want to be less formal. And yeah, then we can continue how to go further. From the Kronos perspective, I have maybe one more comment for physical AI. So Kronos is working on cameras and camera API as well. And it will be an extension of Vulkan. And the question would be to the audience, what other APIs do you need in physical AI which should work together? I guess it would be terrible if you're writing your physical AI operating system and you would have to support a fully different API for each and every device. Mm-hmm. Would it make sense, or doesn't it make sense to unify everything below a single unified API so that buffers could be shared, or resources, or you have common synchronization? Is this a requirement there is or not?
Okay, so actually I'm not a head of optimization team, but from what I've heard, so I don't know about NPU about details, but in NPUs, I do think there will be some kind of common layers, a building block, such as a matrix multiplication. And there are some codes to activate that specific hardware calculation. And there are many architectures such as ARM, x86, that kind of architecture. And so we have experience on NVIDIA's architecture and Qualcomm and many others. But every time you're trying to run any kind of AI system, the AI system tries to run, what do you say, PyTorch and the kind of function level, high level code running. So there needs to be some kind of translator to translate that codes into a hardware level matrix multiplication or something. But the middle layer, I don't think that is, what do you say, abstractized enough. So that is the current development cost associated with commercializing on edge devices. So that's my current take.
Okay. I think since we are basically closing to the end, I think it's a good question. And I think we heard a lot of, I would say, good questions. And as some wise people say that, it's not always, let's put it like this, that it's more important to have a good questions than a good answers. And then usually good answers comes when you are able actually to formulate the question. So I think we have a lot of questions, but I think we also have a better understanding of what is going on, what is, let's say, out there on a physical AI, what are the ongoing activities, and I think now a better understanding between various involved, let's say, organizations and players, what needs to be looked at in the future. And of course, as usual, it's complex, it's not easy, it's not something that will happen from one day to the other, like nothing usually happens. But I think that this type of the discussion, open dialogues, are somehow moving things forward, and I hope that we gave at least that contribution to it. So I would like to ask you to give a thanks to all of our speakers and panelists, and thank you for your attention.
We would like to express our sincere gratitude to moderator Damir and all the panelists and speakers. Please give them another big round of applause, please. Before you leave, we have a short announcement. The Lucky Draw event will begin at 5:40 p.m. in the Hotel Hall on the 5th floor. So the prizes include the Galaxy Buds 3 FE and JBL Bluetooth speaker Go 4. We look forward to your participation. Thank you.